In this demo, I'm going to show you how we can actually build a naive Bayes spam classifier on Alibaba Cloud. So the first thing that we need to do is actually go over to GitHub. I've posted instructions and some code in a Jupyter notebook here that we can use to perform the classification. So if you look in the Alibaba Cloud Academy organization here, which is github.com/alicloud-academy, you'll see there's two repositories right now. What you want to do is look in big data, this one. And inside that repository, there is an item called spam filter. That's where the spam filter code and instructions live. There's a .ipynb file. This is a Python notebook file that you can open with Jupyter Notebook. And then there's the README, which explains how to set everything up. So the first thing we need to do is create a PAI DSW, Data Science Workshop environment. So there's a handy feature inside Alibaba Cloud's PAI that lets you set up notebooks on the cloud. So you don't have to run them on your local machine. And you can choose here, I'll just show you. You can choose your hardware specification, attach a GPU. There's built-in tools like TensorFlow. And it's right here from the PAI console. I go to DSW Notebook Service. And then in here, I can create a new notebook instance, which we will call ham or spam. And then I can choose, does it need a GPU or not? If not, I'll choose CPU. And then I can choose different hardware specifications. The smallest one here is 2 cores and 4 gigs of RAM. And I can either pay upfront or pay as you go. I'm going to pay as you go. And you can attach additional storage in the form of a network attached storage system, an NFS file system. I won't do that. I'll leave that blank because PAI comes with 5 gigabytes of storage by default, and that is enough. Then I'll click OK, and that will go ahead and create my instance. You can see it's in the creating state right now. If I wait a few seconds, it will enter the running state. And I should point out that if you have multiple notebook instances, you'll only be charged for the ones that are in the running status. If you stop the instance, but don't release it, then you won't be charged for the instance. So that's a nice feature. So you can set up multiple different DSW notebooks from within Platform for AI, and you can just stop the ones you're not currently using, and then you won't be charged for those. Let's go ahead and refresh the page, see if our new system is ready yet. Because I am in China, I chose to deploy in the Shanghai region, but you could also deploy in Singapore, Malaysia, Indonesia, India, or Germany. There's quite a few choices here. Okay, oops, there's a little bit of Chinese here. It says that the instance is now running. So I can click on Launch DSW, and that will open up the Data Science Workshop web interface. And this is really cool. So there's a web terminal here where I can not only see and edit and interact with Jupyter notebooks, I can also open a terminal and install third-party software packages for Python 2 or Python 3. And I can also create new files and folders and upload existing files and folders to the interface here. And then I'll be able to access these files and folders from any Jupyter notebooks I create. So we'll be doing that in just a second. Let's figure out what to upload. So from the Big Data Spam Filter folder here on GitHub, I need a copy of this code, this email model code. And then I also need some email data. So if you look at the instructions that I wrote here, you can get the email data from Kaggle. I have a link to a Kaggle data set that includes spam and non-spam messages from the Spam Assassin spam filter people. And I'll go ahead and download that zip file. And then I also want to get a copy of this repository here so that I can get a copy of this ipynb file. So what I'll do is I'll go back to the top level, big data. I will go to code. Okay. Copy that to the clipboard. Let's see where I am. I'm in the downloads folder. I'll do get clone, and then I'll clone into this big data repository. Great. Let's open up a Finder window here. I need to do a couple more things to get the data into Data Science Workshop and start playing with it. Number one, I need to unpack this zip file with my example emails in it. And number two, I need to create a new folder, which I'll call, I don't know. The name actually is not that important. I'll call it email sort. Then from this folder, from this bundle archive folder I got from Kaggle, I just copy and paste ham and spam, this directory, into my new email sort folder. I go into big data, spam filter, and I copy this Python notebook. This includes all the code for parsing emails, reading them in, and training our final model. Great, so now I've got my ham and spam directory, which has spam and non-spam emails that I can use to train and test my model. And I also have the Python notebook containing all of my model code. And that's all in this folder email sort, which I will now compress. So I'll go ahead and turn this back into a zip archive. Great, the final folder is about 8 megabytes. That's okay. And now I'll click on this arrow here to go ahead and upload that to the PAI DSW console. Let me close that download bar. And I'll get an upload dialog that looks like this one. Once my file is uploaded, then we can go about unzipping it. So one of the cool things about the Data Science Workshop in PAI is this is running on a regular Linux machine. So you can open up a terminal tab, and then you can see things you've uploaded. See, there's my zip folder that I just uploaded. And I can run common commands like, say, unzip, and that will unpack all of the emails here. So we just need to wait a few moments for that process to complete. While we're waiting, we can actually open a second terminal, and we need to install a few extra tools in order to parse our email messages successfully. If you take a look at the README, in addition to preparing the data and the code, we have to unpack and install a few extra dependencies. Specifically, we need to install scikit-learn, beautiful soup, which is an HTML parsing library, and LXML, which is an HTML and XML parser tool. So I need to run this command. Actually, this command needs to be updated. You need to add the -- user flag into this command when you run it, because you don't have administrator permissions inside of DSW. You are just a regular user. So what I can do is pip install -- user, and then I want bs4 LXML and sklearn. And that will go ahead and install those 3 Python libraries for me. sklearn, if you're not familiar with it, is scikit-learn. It is a super handy Python library full of all kinds of good data processing, feature extraction, and machine learning model tools. And that's what we'll actually be using to train our classifier. So now all we need to do is wait for unpacking the zip file and installing these packages to finish. And a neat feature in the console in DSW is I can expand this sidebar here and get some information in near real time about CPU and memory usage on my instance, because the Data Science Workshop interface here actually runs on top of a virtual machine, a single virtual machine. And so I can see statistics about how much load that virtual machine is under, and I could upgrade to a more powerful instance if I find that I'm using more CPU or memory than I thought. Okay, the packages we need are now all installed. We just need to wait for the unzip process to finish. So we'll wait a few more minutes for that. While we're waiting, let's have a look inside this folder here. This file, email model, our model file, our Jupyter notebook, is already unpacked from the zip archive. So let's go ahead and look in there. And I'll run you through the code briefly, explain what it does. So in a Jupyter notebook, you break your code into sections. This allows you to run them independent from each other. What I've done here is I have a section at the top which will read in a list of the file names for my ham and spam emails. And remember, ham is not spam. Ham is the good mail that we want to keep. Spam is the bad mail we want to throw away. And then after it reads in this list of file names, it just computes for me how many spam and ham messages it found and what the ratio was between spam and ham. The next module here inside of my notebook actually uses Python's email parser, which is a built-in Python library, to go through all the messages and convert them into plain text. So for plain text mail, this is very easy. I just return the plain text content. For multi-part emails, I go through and I find all of the text and HTML content that I can. And if I encounter HTML content, I use Beautiful Soup to parse it into plain text. So the objective here is to pull out the body of the email, just the body. I don't even look at the headers. Pull out the body of the email for all these spam and ham messages and convert it to plain text. Then once I'm done with that process, this is also more processing steps here to convert things to plain text. Once I'm done with that, I can use scikit-learn. It has a class called count vectorizer, which I can use to go through the ham and spam email sets and then build a dictionary of all the words that I saw and their counts. So this will tell me how many times I saw each word in the ham and spam email sets. That's what goes into X. So this is actually a sparse matrix, and then I have to form a vector Y, which expresses for each of the columns in X, is it a ham email, a good email, or a spam email? And I know this in advance because I have that information, right? My emails were already sorted into ham and spam. And then once that's done, we can actually go about training our model. It's very easy. We use something called complement naive Bayes. If you're curious about what complement naive Bayes is, you can look in the documentation on the scikit-learn website. They go into a lot of detail. It's actually very good documentation. I have a link to it in the body here, I think, of my GitHub page. So we fit the model. After we split the data into a test set and a training set up here. We train our complement naive Bayes on our training data. Then we calculate precision and recall, which, to put it in very, very oversimplified terms, is the accuracy of our model, using, again, built-in precision and recall calculators that are part of scikit-learn. And then we finally make up some fake ham and spam messages and run them through our classifier to see what it does. And of course, before I can feed them to the classifier, I have to convert the words in each of my fake spam messages into one of these feature vectors, which is a count of how many times each word occurs. So you can see I've got a fake ham message, which is like, it has a real name, it's addressed to a person, it's written in a relatively informal, friendly tone. Then I've got my fake spam where it starts with "Dear Sir" or "Madam," and it says "You've received an invite," and then it's trying to sell you something. So we can test to see if the classifier can actually accurately determine which of these is spam and which is not. So let's go ahead and run this whole notebook top to bottom. It looks like our extraction task here is done now. Yeah, it's done. So now we can go and run this whole notebook. So I can go through run, all cells. This will run the entire notebook from top to bottom. You can see we have 500 spam emails and about 2,500 ham emails. So our training set is 20% spam. That's actually not representative. In real life, I think it's the other way around. Almost 80% of email is actually spam. And then here in our second cell, which we're waiting for now, when this finishes, it should dump out the raw content of one spam and one ham email for us to look at so we can make a comparison. Yep, there we go. Here's the first ham message, including the headers. We include the headers here. And you can say, oh, I can't reproduce this error. It looks like it's from a mailing list. And then the first spam message is this bizarre list of numbers. So we can ignore that. And then in order to differentiate ham and spam, we have to develop features. Okay, to do that, again, I extract the raw text so that I can ignore all that garbage and header stuff that you just saw in the raw emails. Once I've extracted just the content, I end up getting legitimate emails that look like this and spam mails that look pretty much like that, pretty much the same, because this was already plain text. And then I train my model, and we calculate the precision and recall. It's very good. It's catching more than 95% of spam. It's doing very, very well. And if I try it on my fake messages, I can see that it classified my ham message, my legitimate message, as 0, which is correct. 0 means it's ham. And it classified my spam message as 1, which is correct. That means spam. So it's doing quite a good job. And actually, this thing here, this spam message, looks like it's actually an artifact. So this is one of the cool things about DSW. You can go into the command line, like I'm doing now, go into the ham and spam folder, go to spam, and see and play with the original data. So I happen to know that there's a file in here that starts like this, 0000 dot. That file is actually a list of the other files that are part of this spam list. It's not an email. So what I can do is I can then remove that, and then I can restart my kernel and rerun all the cells. And when I do that, at these middle steps here where I'm looking at the example ham and spam emails, I should get different output because that first spam result was thrown off by that non-email file that I just deleted. So I can delete and manipulate files from the command line in here just as though I was on my own Linux machine in my own house. All right, so great. Here's our ham message. And let's have a look at spam. Okay, so now we've got a real spam message. That's great. Financial history, life insurance. Okay, so they're selling you life insurance. Okay, and again, I can process those into plain text. Life insurance, why pay more? I can tell that's spam right away. When I train my model now, I get even better precision and recall than I got before, and my fake messages are still classified correctly as ham for the first, spam for the second. And feel free to change these. Change this code. Write a different fake real email and a different fake spam email and see what happens. See if the classifier gets it right. Okay, that's it. That's all I wanted to show you. You can, of course, also take models that you build in the Data Science Workshop and export them to PAI EAS, the Elastic Algorithm Service, which lets you take all this hard work you've done in DSW and convert it into an API service that can return judgments or classes or predictions that your model makes. So that's really cool. You can make an API endpoint here in EAS that will take this model, and for any spam you feed it, it will be able to say, yes, this is spam, or no, not spam, by returning, say, a 0 or a 1 in an HTTP request. Okay, thank you very much for joining me for the demo. Again, I encourage you to check out the instructions and the code here on our GitHub page, Ali Cloud Academy, to make sure that you have a better understanding of how this all works, play around with it a little bit more. And again, thank you, and I'll see you in the next demo.